This lesson goes with lesson 2.4, and we are once again looking at dividing a whole number by a fraction. So we looked at this in the last lesson as well, but we're going to be looking at some fractions that are a little bit more complicated. So we did the do now, and there actually wasn't any homework. So we're going to get right into this. So let's think about some of the problems that we did last time, okay? So if you look at this first problem, and we noticed that there was definitely something going on here, that we saw the connection between the 4 and the 6 and the answer that we got. So we then knew that 4 times 6 over 1 was the same as 4 divided by 1/6. Same thing for this problem. We saw a connection between the two numbers involved and the solution, and that told us that we could also write this, instead of 4 divided by 1/4, it's 4 times 4 over 1. And we knew that would be the same thing. So we could do the same thing for these other problems, right? So we have 4 divided by 1/3. We could write that as 4 times 3 over 1. And we know, of course, that that's 12. And for this last one, we know we could write that as 4 times 2 over 1. And again, using fraction multiplication, we know that's equal to 8. So that's just a quick reminder of what we did last time. So we've been working with these paint problems, and they're just a really good way to draw some pictures to help us understand how to do some division with fractions. So let's take a look at this problem. I'm going to highlight some of the important pieces here. It says that Avery has 6 gallons of paint, so of course that's important. And she's painting small desks, and it takes her 2/3 of a gallon to cover a small desk. How many small desks can she paint? So notice that we have 6 boxes, and each of those boxes represent a gallon of paint. And we need to know how many 2/3 of a gallon can we divide those 6 boxes into. So because I'm dealing with thirds, I'm going to start breaking up my boxes into thirds. So I'm going to do the best I can here. It's never going to be perfect, but maybe something like this, right? I'm going to do all of them. And again, just dividing into thirds the best I can. But these small desks take 2/3 of a gallon. So I'm going to color some of these in a little bit. All right, so this represents 2/3. And I have another 2/3. And I have another 2/3. And so on. And you can see how this is working. And I'm going to keep looking at this as groups of 2/3. And we're almost done here. And it looks like it works out evenly, which is nice. So the question I have is, how many of these groups of 2/3 are there? So let's start counting. I see 1, I see 2, and there's 3, and 4, and 5, 6, 7, 8, 9. So that tells me I can divide these 6 gallons into 2/3, and I can get 9 of those. So each of these numbers represents the small table that I can paint. Each of these groups represents a 2/3. And then I can write a division statement based on this, right? So I can say that when I divide 6 by 2/3, I know that that now equals 9. Okay? Now I'm going to write a multiplication table, or multiplication sentence as well that goes with this. And I just want you to think about this. I'm going to write 6 times 3/2. And I want to see if you can do the multiplication for that for me. And I'm going to have you stop the video and do that. And then we'll see how you do. So if you do the multiplication, you should get 18/2, and you can simplify that to also get 9. So 6 divided by 2/3 is 9, and 6 times 3/2 is 9. All right, so keep that in mind, and we will look at another example. So this problem is similar, and we're going to highlight some important aspects of it again. Avery has 6 gallons of paint, again, starting with that 6 gallons. This time she's painting large desks, so it's going to take a little bit more paint. Instead of 2/3, it's going to take 3/4 of a gallon of paint to cover a large desk. And once again, the question is, how many large desks can we paint? So we're going to try to divide these 6 gallons of paint into 3/4. So to do that, I'm going to divide each box into fourths. And again, I'm going to do that the best I can. So if I divide it in half and then in half again, that's probably the easiest way to get fourths. Something like this. And then I'm going to color every group of 3, which will represent 3/4. So these 3, and then these 3, each of these representing 3/4 of a gallon of paint. And I'll do this the whole way through. And almost done. So the question is, how many 3/4 are there in these 6 gallons of paint? So once again, I'm going to count. Here's 1, here's 2, here's 3, here's 4, 5, 6, 7, and 8. So once again, I can write a division statement. These 6 gallons of paint, when I divide it into 3/4, I know that gives me 8 groups. And once again, I'm going to try to write this as a multiplication problem as well. I'm going to write 6 times 4/3. And I want you to stop the video again and calculate that for me, and then we'll see how you did. So if you do the fraction multiplication, you should get 24/3. and that simplifies to 8. So 6 divided by 3/4 equals 8, and 6 times 4/3 equals 8. So now we're going to see if we can see a pattern here that's going to help us better divide a whole number by a fraction. Now I want you to look more closely at how we go from the division statement to the multiplication statement. So I want to think a little more deeply about how we go from here to here. So if I look between the two equations, a few things happen here. So both of them start with the same number, okay? So we start with the 6. So we are keeping the first number, and then I'm going to look what happens to the multiplication, or the division. The division then becomes multiplication. So we are changing from division to multiplication. So we change the operation from division to multiplication, and then when we go from the division problem to the multiplication problem, note what happens to the fraction. We have 2/3 and we have 3/2. So we are flipping the fraction from 2/3 to 3/2. So to convert from the division to multiplication, we first keep the first number, we change the operation, and we flip the fraction. And we know that when we do that, we get the same answer. All right, so does this still hold for the second example that we did? Let's find out. Does the keep, change, flip process work here as well? So yes, you can see that when we went back and forth, we kept the 6. Then we changed the operation from multiplication to division. And then when you look at the fraction, it went from 3/4 to 4/3, so we flipped it. And we know that we get the same answer. So once again, the key here is we keep the first number, we change the operation from division to multiplication, and then we flip the fraction, and then we complete the multiplication. So let's look at one last quick example to make sure we have this process down. So let's say I want to divide 8 by 2/3. So I'm going to follow this process. I'm going to keep the 8, change the operation to multiplication. I'm going to flip the fraction, and then I'm going to do the operation. So that's going to give me, if I do my fraction multiplication, I'm going to do 8 times 3 on the top. When I put the 8 over the 1, that gives me 1 times 2 on the bottom. And that makes my final answer 12. All right. Again, the key is keep, change, and flip. All right, so you can go back to Google Classroom and try try the assessment there and see how you do. Let me know if you have any questions.